So I want to add a fourth state where the AI flees from the player. So I want this now to look like this. I want now to have my character flee. It takes a while for this to start, and it's abysmally slow when we're zooming. So there, the character ran away. Now it's chasing. Now it's jumping. If I go too close, where'd he go? He runs away. So now I can chase my AI around, and he'll chase me when it comes closer. So to do this, I'm going to add two new public distances, a far distance that I want to be larger than the jump distance, and a close distance that I want to be less than the jump distance. So these are kind of my two circles that we had before when we did the pet AI. And I'm going to have two new tests, too close and too far, and their companion private Booleans, too close and too far, to catch results of the test. Our state diagram is now a little more complicated. This part is all pretty much exactly the same way. But now from each of these states, I've got a transition that if they're too close, I'm going to go to the flee state, and the flee state will stay in the flee state until we're far enough away, at which point it'll go back to the idle. So our state diagram is now a bit more complicated. In the update function, let me show you that state diagram. So again, this part is pretty much all the same, but now each of these have transitions to the flee. This could have been done with the any state. The any state will transition from any state to a flee state. But since I only had 3 of these and it made it easier to trim up the animations to match, I did it here. So the update functions, I'm adding my 2 new tests, too far and too close, stored into the Booleans, too close and too far. I'm setting those Booleans too close and too far. These are now parameters that I've got in here that are controlling this. And my logic gets a little more complicated. My logic gets a little more complicated. If I'm too close, I flee. Otherwise, I go through the usual tests of can see, can jump, and not too far, and jumping and chasing and idling. So the logic is almost the same, a little more complicated. The flee function is pretty much identical to the chase function. The only difference being that I minus the wanted direction. So the addition of this minus sign is all that I had to do to make the flee function work properly. This turns the direction that my character wants to go away from the target instead of towards the target. That's the only change. The new controller, I just showed you that. Flee is a blend tree like chase, using run left, run, and run right animations. That flee is a blend tree, and it's using the direction just like the chase did. Now, the character here takes forever to start. The character here can still see me through this little wall. He doesn't like it when it bumps up against the wall. So he can still see me through the wall, and so he still chases me. But so I want to add a little feature here. I want to add a little feature here that is going to check the line of sight to see if there is an obstacle between my AI and its target character. And so I'm going to add a function, check line of sight. And check line of sight uses something called a raycast to see if we have a line of view to our target. And here's where the eyes come in. I've got my eyes position that is going to be up where a little object that I put up where the head is, so that it's not checking the line of sight from the root center of the AI, which is unfortunately where its feet are. So I form a vector between the target position and the source position, and I do a physics raycast from that source position where the eyes are in the direction of my target. It's going to return a hit, and it's going to cast out to some distance. If the hit is the target, then I return a true, otherwise I return a false. So this is going to let me see my target only if there's nothing in between the AI and its target. So I need a bailout now. If I can't see them, if the check line of sight is false, I'll return a false. And I'll add this to the beginning of each of the can see, can jump, and to close functions so that they return false if we don't have a direct line of sight to our player. This is going to allow our player to hide from the AI. The raycast is pretty powerful. It has the origin of the raycast, where the cast starts. That's at my eyes. It's in a direction, a vector. It returns a raycast hit, which you have to put the keyword out in front of. And it also has a distance, which by default is infinity. This is a raycast that goes on forever. But since my eyes can only see a certain distance, I'm putting the sight distance in there. The raycast hit data type has a lot of information about what it's hit. It has the point in space that the hit is. This would be where that raycast hits a target. It has the distance to that point. It has the collider that it's hit. It has the rigid body that it's hit, and it has the transform that it's hit. I'm catching the transform that it's hit and testing to see if it's the same as our target. Here's that C distance. This is how far it can see. Here's that out hit, raycast hit data type that we're using to see things. If the raycast doesn't hit anything, if we're looking at empty space, this will return a false. It returns a true if it hits something. These little gizmos, the lines that I'm drawing so that I can kind of see what my AI can see, are done with a draw ray. Here, emanating from the source position, the ray emanates from a source position in a direction. I'm using the line of sight vector normalized times my C range or sight distance. And now with this, I can now include a wall in my scene. So here's line of sight. Again, we'll fire this up and wait the appropriate amount of time for it to kick in. Takes forever. So there are a bunch of different lines in here. You can see what they are. Now I can hide behind the wall. I can get real close to the character, and even though he's can see me, I mean, even so I'm within distance, he's continuing to search. If I move outside around the wall, he now, of course, sees me right away, starts chasing me, starts jumping, and I can chase him. And let me force him over the hill here. And I can actually hide behind terrain here. Now I'm just too far away for him to see. If I drop behind the terrain, he can't see me when I'm behind the terrain. He can when I am. So clearly we have a situation where we can take advantage of hiding spaces behind terrain, and we can take advantage of obstacles in our world that let me hide from the character. So a lot of capability added here with our line of sight. So I'm going to stop here, but next thing I'm going to do is replace that jump state with an attack state where the AI chases the player and when it's close enough attacks. But I'm going to do that in the next lecture. So I'll stop there, and I'll see you all in class. I'm going to end the recording now, and I'll see you all in class. Goodbye.